Alright, so I think I'm recording. We're looking at review problems from Skill Packet 3, Relations and Functions. We have several problems I'm going to do here right in a row. The directions are the same. Does this relation represent a function? And maybe it should really say represent y as a function of x, because that's how we've defined it to be. If you have an equation, what you want to try to do is solve the equation for y by getting y by itself. So if I add y cubed to each side, that'll get the y cubed by itself. So I'll have 5x squared plus 11 is equal to y cubed. And I'm going to write the y on the left-hand side. If I take the cube root of that, I'll just get y. And if I take the cube root of the left-hand side, I have to take the cube root of the right-hand side. When we take odd roots, we don't have to introduce a plus or minus sign. And we have in our library of, well, I guess this is x cubed. This isn't really a cube root of x. So every x that we put in here, you can play around with it and pick any x that you'd like, because the domain is all real numbers. We don't have a variable in the denominator, and the expressions underneath an odd root do not have to be non-negative. It can be any real number. So the domain for this is all real numbers, and you'll get exactly one y value for any x that you plug in. So yes, this is a function. Well, sometimes it's going to be really challenging to get y by itself, So we've noticed in doing these problems on homework that there's a little bit of a shortcut. And that shortcut is focusing our attention on the exponent on y. As long as there's no symbols like absolute value symbols around that y, as long as there's no symbols in the equation like a plus or minus indicating that there's really two equations, one where you're adding and one where you're subtracting, if we don't have any of those plus minus symbols and we don't have any absolute value symbols around the y, if it's an odd exponent, it's going to represent a function. And if it's an even exponent, it's not, because an even exponent, when you take the even root of both sides, you are going to have to introduce a plus or minus, which means that for that x you have two equations, one where it's positive, one where it's negative. We'll see that in more detail here in a minute. But the thing to take away from it, solve for y. If you can't do that, examine the exponent on y. If it's odd and there's no absolute value symbols or plus or minus symbols in the equation, it's going to be a function. If it's even, it's not. If there's a plus or minus anywhere in there, it's not. If there's absolute value symbols around the y, it's not going to be a function. So let's take a look at number 11. Well, I was just saying that even though the exponent on y is odd, that because there's absolute value symbols around this is not a function. We can come up with values of x that are related to more than one y value, because if you go to graph something that has the absolute value of y, it opens to the right rather than opening up or down, and it fails the vertical line test. So I'm sure it would not be too hard to, if we had x equals 2, are we going to get what y values would this produce? So if x is equal to 2, I have 6 times 2, which is 12, and 12 plus 2 is 14. So, oops, I lost my other absolute value symbol. This y minus 1, the absolute value of 14 is 14. See, the number that's underneath here, you can see right through it, I guess that doesn't. The value that we're taking the absolute value of, we know that the absolute value of negative 14 is positive 14. So y minus 1 might represent a negative 14, because if you replace this with a negative 14, you'll get a true statement. Or this y minus 1 could represent positive 14. So when x is 2, y might be a negative 14, or y might be 15. So you've got 2 that's related to negative 13, but 2 is also related to 15. This is not a function. And so we don't have to go through that process every time. We sit there and say, hey, when I see absolute value symbols around that y variable, it's not a function. What about this equation? Well, I don't see any absolute value symbols around y. Y is to the odd power. It'd be really easy to solve this for y. We've got subtract x from each side, negative x plus 1, divide by 3, and we've got negative 1/3 x plus 1/3. Hey, that's the equation of a line. It has a slope of negative 1/3 and a y-intercept that's positive 1/3. So yeah, here's my y-intercept of 1/3. Here's a line with a slope, say, of negative 1/3. That passes the vertical line test, and we have a linear function. So yes, this is a function. We could quickly apply our rule of thumb that since the exponent on y was odd and there were no absolute value symbols around y, there were no plus or minus symbols, there were no other functions that we weren't taking something that's called the logarithm of y, or we weren't taking a greatest integer function, or we weren't taking a sine or cosine. We weren't applying any other functions to this equation. So yes, this is a function, and it would be referred to as a linear function. Well, now here we have something interesting. We don't have a y value. So this relation x equals 8, well, in the contents, we're supposed to understand that this is just not a single value of 8, that this equation in the plane, in the real plane, in a two-dimensional plane, if we graph a vertical line and we look at multiple points on this line, the one thing all of these points have in common is they all have an x-coordinate of 8. Maybe this guy over here is 8, 5. Maybe this guy is 8, 4. Maybe this guy down here is 8, negative pi. Maybe this is 8, negative 5. We don't know what they are, but we can clearly see that it's not a function because we have 8 that is related to more than one y value. Every element in the domain has to be have a unique relationship to a value in the range. Unique meaning exactly 1. When we say what is 8 related to, oh my gosh, we have infinitely many answers. This is not a function. It fails the vertical line test in the worst way. I can find a vertical line that intersects that line infinitely many times. And if it intersects it more than once, it fails. So if I just draw a vertical line on top of this vertical line, well, like I say, 8 is related to any real number you want. This is not a function. Now, a horizontal line is a different case. A horizontal line passes the vertical line test. A vertical line only intersects that graph in one place. All right, so those were the determine yes or no. Another one that we didn't see, let's talk about real quick. Suppose I had x and it had plus or minus 1. This is shorthand notation, meaning that I have two equations, that y is equal to x minus 1 or that y is equal to x plus 1. So if I had something like x equals 2, over here 2 minus 1 is 1, over here 2 plus 1 is 3. So 2 comma 1 would be on the graph or in this relation, and 2 comma 3. So this relation is not a function because we have an x coordinate that's in the domain of this relation that's related to more than one y value. It has to be exactly one y value. Every input has to have exactly one output for it to be a function. So if you see a plus or minus symbol, no way, Jose, can that be a function. If you see absolute value symbols around a y, can't be a function. If you see an even exponent on y, it can't be a function. We want the exponents to be odd, and we don't want any symbols around the y. So I hope that helps.